Node.js version 14.8.0 documentation on API/modules. Modules. Stability to stable. In the Node.js module system, each file is treated as a separate module. For example, consider a file named foo.js. Const circle equals require within quotes dot/circle.js. Console.log within quotes the area of the circle of radius 4 is $, open curly brace, circle.area, open paren 4, close paren, close curly brace, close quotation. Oh, these quotes are backticks, by the way. I think that's important because we're using, they're backticks because we're using the $ semantics here for replacing, for like formatting strings. On the first line, foo.js loads the module circle.js that is in the same directory as foo.js. Here are the contents of circle.js. Const pi equals math, so that's a deconstructor that's going to take math.pi and assign it to a variable called pi. Exports.area equals open paren r, close paren, equals, and then a greater than. So let me say this again. It's an arrow function assigned to exports.area. It takes parameter r, radius, and the calculation is pi multiplied by radius, and then 2 stars, which I believe is to the power of, and then a 2. I didn't know you could do that in Node.js. I'm pretty sure that must be a Node.js thing, or maybe that's a new ES6 thing for the power operator. Exports.circumference equals parameter r, and then there is an arrow function, and the calculation is 2 multiplied by pi, and then multiplied by r. Note that there's no curly braces around this, and when you do not include curly braces, the expression becomes the return value. It's like a shorthand way to do that. Let's keep on going. The module circle.js has exported the function area and circumference. Functions and objects are added to the root of the module by specifying additional properties on the special exports object. Variables local to the module will be private because the module is wrapped in a function by Node.js. See module wrapper. In this example, the variable pi is private to circle.js. The module.exports property can be assigned a new value, such as a function or object. Let's scroll down. Below, bar.js makes use of the square module, which exports a square class. Const square, capitalized, equals require square.js. Const mysquare equals new square, and 2 as the parameter. Console.log, the area of my square is, and within a format token, there is a $ open curly brace my square.area invoked with a open paren, close curly brace, and the whole thing is within the whole string is within backticks. The square module is defined in square.js. Assigning to exports will not modify module, must use module.exports. Module.exports equals class square, open curly brace. Constructor taking a width parameter. The body of the function is this.width equals width. We have is that really can you really declare a function like that? Sorry, that's just kind of weird that, so I find it kind of weird that area is declared without, I'm going to guess that's a shorthand way to create a member function, and I'm not familiar with the syntax. So it's just area, open paren, close paren, open curly brace, a statement, and then a close curly brace to close off the function. And within the function, it's returned this dot width and then to the power of 2. Let's keep going. The module system is implemented in the require module accessing the main module. When a file is run directly from Node.js, require.main is set to its module. This means that it is possible to determine whether a file has been run directly by testing require.main equals module. For a file foo.js, this will be true if run via node foo.js, but false if run by require, and then within quotations, /foo. Because module provides a file name property, normally equivalent to __ file name, the entry point of the current application can be obtained by checking require.main.filename. Addenda. Package manager tips. The semantics of Node.js require function were aligned to be general enough to support reasonable directory structures. Package manager programs such as D, PKG, RPM, NPM will hopefully find it possible to build native packages from Node.js modules without modification. Below we give a suggested directory structure that could work. Let's say we wanted to have the folder /user /lib /node /some package /some version hold the contents of a specific version of a package. Packages can depend on one another. In order to install package foo, it may be necessary to install a specific version of package bar. The bar package may itself have dependencies, and in some cases these may even collide or form cyclic dependencies. And that would be bad. Since Node.js looks up the real path of any module it loads, that is, resolves symlinks, and then looks for their dependencies in the Node modules folders as described here, this situation is very simple to resolve with the following architecture. We have some bullet points here. Let me scroll down. /user /lib /node /foo /1.2.3 / and then it says : contents of the foo package version 1.2.3. From now on, when I say slash, I mean /. Bullet point /user /lib /node /bar /4.3.2 / and then : contents of the bar package that foo depends on. Bullet point /user /lib /node /foo /1.2.3 /node _modules /bar. Symbolic link to user /lib /node /bar 4.3.2. Bullet point /user /lib /node /bar /4.3.2 /node _modules /star. Symbolic links to the packages that bar depends on. So let's give that a quick look over for a second. So basically we have users /lib /node, and that's pretty common. That's a common between all of these four paths is user lib node. And then we have two branches from there, either foo or bar. And you can take either the foo or bar branch, and then after you are in either foo or bar, you can either take the 123 branch or the 432 branch. So we kind of like split twice after the node folder is what's going on there to like visualize the structure a little bit more. Thus, even if a cycle is encountered or there are dependency conflicts, every module will be able to get a version of its dependency that it can use. When the code in the foo package does require bar, it will get the version that is symlinked into /user /lib /node /foo /1.2.3 /node _modules /bar. Then, when the code in bar package calls require, and this is quoted, QUUX, it will get the version that is symlinked into /user/node/lib/bar/4.3.2 slash node modules slash QUUX. Okay, let's scroll down a bit. Furthermore, to make the module lookup process even more optimal, rather than putting packages directly in /user/lib/node, we could put them in /user/lib/node_modules/ and then these are wildcards, like anything you could put in here. So name /version. So name and version are your name and your version. Then Node.js will not bother looking for missing dependencies in /user/node modules or /node modules. In order to make modules available to Node.js REPL, it might be useful to also add the /user/lib/node modules folder to the $node_path environment variable. Since the module lookups using node modules folders are all relative and based on the real path of the files making the calls to require, the packages themselves can be anywhere. Okay, so you have another addenda. Addenda, the .mjs extension. It is not possible to require files that have the .mjs extension. Attempting to do so will throw an error. The .mjs extension is reserved for ECMAScript modules, which cannot be loaded via require. See ECMAScript modules for more details. Altogether, to get the exact file name that will be loaded when require is called, use require.resolve function. Putting together all of the above here is the Putting together all of the above here is the high-level algorithm in pseudocode of what require does. Require x from module at path y. 1. If x is a core module, a, return the core module, b, stop. 2. If x begins with /, a, set y to the file system root. 3. If x begins with // or // or .. load as file y plus x, load as directory y plus x, throw not found. So those are like 3 options, I'm guessing. If x begins with a #, a hashtag, an octothorpe, too many names, or a hashtag, I guess you could also call it a hashtag. Well, anyways, if x begins with a #, a, load internal import x, y. And this looks like a syntax error because we have 4 is repeated again. Step 4, load self-reference x, y. 5, load node modules x, dir name y, throw not found. Okay, load as file x. 1, if x is file, load x as its file extension format, stop. 2, if x.js is a file, load x.js as JavaScript text, stop. 3, if x.json is a file, parse x.json to a JavaScript object, stop. If x.node is a file, load x.node as binary add-on, stop. Load index x. 1. If x/index.js is a file, load x/index.js as JavaScript's text, stop. If x/index.json is a file, parse x/index.json to a JavaScript object, stop. 3. If x/index.node is a file, load x/index.node as binary add-on, stop. Load x as directory x. 1. If x/package.json is a file, a, parse x/package.json and look for main field. B, if main is a falsy value, go to 2. C, let m equals x plus JSON main field. D, load as file m. E, load index m. F, load index x, deprecated. G, throw not found. 2. Load index x. Load node modules, taking parameters x and start. 1. Let dirs equal node module paths start. 2. For each dir in dirs, we're going to do A, B, and C. A, load package exports with params dir and x. B, load as file name with parameter dir divided by x. Or that might be dir / x, more likely, because it's a path. C, load as directory dir / x. Okay, next function in here. Node modules paths with a parameter start. 1, let parts equal path.split start. 2, let I equal count of parts minus 1. 3, let dirs equal global folders within square brackets. 4, while I is greater than or equal to 0, we're going to do A through D. A, if parts I equal node modules, continue. B, dir equals path.join parts 0 to I plus node modules. C, dirs equals dirs plus dir. D, let I equal I minus 1. 5, return dirs. Load self-reference, parameters x and start. 1, find the closest package scope to start. 2, if no scope was found, return. 3, if the package.json has no exports, return. 4, if the name in package.json is a prefix of x, then A, load remainder of x relative to this package as if it was loaded via load node modules with the name in package.json. Load package exports dir, x. Try to interpret x as a combination of name and subpath, where name may have a at scope / prefix, and the subpath begins with a /. If x does not match this pattern, or dir / name / package.json is not a file, return. 3, parse dir / name / package.json and look for exports field. 4, if exports is null or undefined, return. 5, if exports is an object with some keys starting with dot and some keys not starting with dot, throw invalid config. 6, if exports is a string or object with no keys starting with dot, treat it as having that value as its dot object property. Okay, we're going to scroll down here, and we are on step 7. If subpath is dot, then exports does not have a dot entry, return. If subpath is dot and exports does not have a dot entry, return. 8, find the longest key in exports that the subpath starts with. 9, if no such key can be found, throw not found. 10, let resolved equal file to URL path, package exports target resolve, invoking path to file URL, invoking dir / name, and then I'm close paren, and then another argument, exports key, another parameter, subpath.slice, key.length, another parameter, an array with 2 elements, node in quotes and require in quotes, and then close paren as defined in the ESM resolver. So that's a pretty big chunk. Probably did not read that in a way that makes sense, so I'm going to say step 10 again, verbatim this time. So step 10, let resolved =, file URL to path, open paren, package exports target resolve, open paren, path to file, open paren, dir / name, close paren, comma, exports, open square bracket, key, close square bracket, comma, subpath.slice, open paren, key.length, close paren, comma, open bracket, double quote, node, double quote, close, comma, open double quote, require, close double quote, close square bracket, closing paren, comma, as defined in the ESM resolver. Okay, let's keep on scrolling down here. If the key ends with / A, load as file resolved, B, load as directory resolved. Otherwise, A, if resolved is a file, load it as its file extension format, stop. 13, throw not found. Load internal import parameters x and start. Steps 1 through 5 for this function. 1. Find the closest package scope to start. 2. If no scope was found or the package.json has no imports, return. 3. Let resolved equal file to URL path, open paren package internal resolve, open paren x, comma, path to file URL with parameter start, close paren, comma, as defined in the ESM resolver. 4. If resolved is not a valid file, throw not found. 5. Load resolve as its file extension format, stop. Catching. Modules are catched after the first time they are loaded. This means, among other things, that every call to require foo will get exactly the same object returned if it would resolve the same file. Provided require.cache is not modified, multiple calls to require foo will not cause the module code to be executed multiple times. This is an important feature. With it partially done, objects can be returned, thus allowing transitive dependencies to be loaded even when they would cause cycles. To have module execute code multiple times, export a function and call that function. Module caching caveats. Modules are cached based on their resolved file name. Since modules may resolve to a different file name based on the location of the calling module loading from node_modules folder, it is not a guarantee that require foo will always return the exact same object if it would resolve to different files. Okay. Additionally, on case-insensitive file systems or operating systems, different resolved file names can point to the same file, but the cache will still treat them as different modules and will reload the file multiple times. For example, require ./foo, all lowercase, and require ./foo, all uppercase, return two different objects irrespective of whether or not .foo and .foo are the same file. Okay, so be careful with case. Probably being consistent with case would be a good idea there. Core modules. Node.js has several modules compiled into the binary. These modules are described in greater detail elsewhere in the documentation. The core modules are defined within the Node.js source and are located in the lib / folder. Core modules are always preferentially loaded in their identifier. Core modules are always preferentially loaded if their identifier is passed to require. For instance, require HTTP will always return the built-in HTTP module, even if there is a file by that name. So core modules trump other modules. Cycles. When there are circular require calls, a module might not have finished executing when it is returned. Consider this situation. So we have a file called a.js, console.log, a is starting, exports.done equals false, const b equals require ./b.js, console.log in a b done equals, and we have a %j, comma, b.done. Okay, so we have like a C style printf kind of statement in console.log. Okay, so exports.done equals true, console.log a.done. Okay. And then we're going to look at b.js. Console.log b starting, exports.done equals false, const a equals require, ./a.js, console.log in b a done equals %j a.done. Exports.done equals true, console.log b done. Okay, and then so there are two files that are importing each other, basically. That's really what you got to know. Two files that are importing each other, what happens? In main.js, console.log main starting, const a equals require ./a.js, const b equals require .b, const b equals require ./b.js. Console.log in main, a done equals %j, b done equals %j, and then it has comma a.done, comma b.done. And honestly, I don't think this should be allowed, but whatever. I would not structure code like this. I would have a third package that has things that are common to A and B, and then A and B both can require that third package. But let's just see what happens when you do something stupid like this. When main.js loads a.js, then a.js in turn loads b.js. At that point, b.js tries to load a.js. In order to prevent an infinite loop, an unfinished copy of a.js exports object is returned to the b.js module. Okay, unfinished copy. b.js then finishes loading, and its exports object is provided to the a.js module. By the time main.js has loaded both modules, they're both finished. The output of this program would thus be, okay, let's take a look. We have node main.js, main starting, a starting, b starting. In b, a done equals false, b done. In a, b.done equals true, a done. In main, a.done equals true, b.done equals true. Okay, so a starts before b, and a starts before b, but we see in b, a.done equals false. So it looks like a kind of short-circuited there, and that's why we're seeing the in b, a done first. Then it does b.done, and then it almost looks like after b is done, and b got completed with the unfinished copy of a, then it looks like there's some type of like paused execution unwinding, because then we go back to a, and we're in a, b.done equals true, and then we have a.done. So in main, and then both of them are completed at the end. So I'd say there's kind of a execution pause, like a yield almost. Like a yield statement would probably be the best way to say it. So a starts loading, and then it yields, and it returns an unfinished copy of itself. Then b starts loading, b finishes, and then wherever a had left off while it was loading, it continues from there. That's kind of how I'm reading that. That's my guess. Okay, so let's see what this says. Careful planning is required to allow cyclic module dependencies to work correctly with an application. I would just avoid it. I'm going to guess that because JavaScript is such a complete and utter mess, especially with like NPM, that it just had to be allowed in the ecosystem. Otherwise, I don't know. I don't know what you would do. File modules. If the exact file name is not found, then Node.js will attempt to load the required file name with the added extensions .js, .json, and finally .node. So in the order of priority, it'll try .js, .json, and .node. And it sounds like it's just going to do like a try-catch with that. So it's not like, hey, let's check the file headers, let's check the file headers, let's check the file headers. We're just going to do a try-catch and hope it works. That's kind of how I am interpreting that sentence. I could be totally wrong. They could be doing something less dirty with the implementation, but that's not the way that sentence sounds to me. .js files are interpreted as JavaScript text files, and .json files are parsed as JSON text files. .node files are interpreted as compiled add-on modules loaded with the process.dlopen. Process.dlopen is the Linux version of, God, what is it called in Windows? Oh, maybe dlopen is the Windows version. Hold on. Hold on. So I'm just gonna take a look. dlopen Windows. So in Windows, what is it called? Load library. Yeah, load library. Okay, yeah. So I'm not going crazy. Okay, so yeah. So process.dlopen, and that would be the Windows equivalent of dlopen here would be load library. And I'm just going to write that down really quick. Windows version of dlopen. That is load library. Okay. And maybe just dlopen in Windows. Okay, so let's keep going. A required module prefixed with a / is an absolute path to the file. For example, require /home /marco /foo.js will load the file at /home /marco /foo.js. Okay, scrolling down here. A required module prefixed with // is relative to the file calling require. That is, circle.js must be in the same directory as foo.js. For require, circle ./circle to find it. Without a leading / or ./ or .// to indicate a file, a module must either be a core module or is loaded from a node_modules folder. If the given path does not exist, require will throw an error with its core property set to module not found. Folders as modules. It is convenient to organize programs and libraries into self-contained directories and then provide a single entry point to those directories. There are 3 ways in which a folder may be passed to require as an argument. The first is to create a package.json file in the root of the folder, which specifies a main module. An example package.json file might look like this. Okay, we got a open curly brace and a closed curly brace, and between that we have 2 key value pairs. We have the key name, which has the value some library, and that is in quotation marks. We also have the key main, and within quotation marks we have ./lib/some library.js. Okay, let's keep going. If this was in a folder at ./some library, then require ./some library would attempt to load ./some library /lib/some library.js. So if this was in some folder at /some library. So that seems kind of like a stuttering path. So they're saying that if this code was actually in a file that was in a folder called some library, that you're already in some library, but it's going to go ./some library. So that would be basically mean that it would be some library /some library /lib/some library.js. That seems slightly redundant. Maybe I'm interpreting that wrong. This is the extent of the awareness of package.json files within Node.js. Good practice, I would say, is don't imply things. You might be an expert at Node.js and you think saving a few keystrokes is nice. But somebody else who's new to the team and unfamiliar with the code base is going to benefit greatly by being very explicit with your paths when you're coding things out. Okay, so if there is no package.json file present in the directory, or if the main entry is missing or cannot be resolved, then Node.js will attempt to load an index.js or index.node file out of that directory. For example, if there was no package.json file in the above example, then require /some library would attempt to load. 2 bullet points here. Bullet point number 1, /some library /index.js. Second bullet point, /some library /index.node. Scrolling down. If these attempts fail, then Node.js will report the entire module as missing with the default error. Error, cannot find module some library. Okay, so that error message is pretty important because knowing why you see that error message will kind of tell you where you probably screwed up in your code. Loading from Node Modules folder. If the module identifier passed to require is not a core module and does not begin with / or .. or /, then Node starts at the parent directory of the current module and adds / node modules and attempts to load the module from that location. Node.js will not append node modules to a path already ending in node modules. Okay, so it's a little bit smart, and if you want to be explicit and put that it's somewhere in node modules, you can do that and you won't have any problems. If it is not found there, then it moves to the parent directory and so on until the root of the file system is reached. For example, if the file at /home /ry /projects /foo.js called require bar.js, then Node.js would look in the following locations in this order. We have 4 bullet points. Number 1, /home /ry /projects /node modules /bar.js. From now on, I'm going to omit the /. Just assume between everything I say, there's a /. Bullet point number 2, home, ry, node modules, bar.js. Bullet point number 3, home, node modules, bar.js. Bullet point number 4, node modules, bar.js. This allows programs to localize their dependencies so that they do not clash. It is possible to require specific files or submodules distributed with a module by including a path suffix after the module name. For instance, require example module /path /to /file would resolve path to file relative to where example module is located. The suffixed path allows the same module resolution semantics. It is possible to require specific files or submodules distributed with a module by including a path suffix after the module name. So I'm not really sure what the path suffix is for. Is that saying that when you put that path suffix, it's like relative? Or I don't know. I mean, we already have /, so I don't really know. Or you know what, it probably means relative to a module that's like somewhere else besides the file that you're currently in. So like, so right here where it's, where are we? So right here where it's example module, you might be in like some other example module, and you're typing this in some other example module, and so we don't want to be relative to some other example when we take this. We want to be relative to whatever this module is. So that's kind of what I'm assuming there. That seems kind of wonky and weird and could trip somebody up. I mean, if you have to do it that way, you have to do it that way, but I would hope that there would be a simpler, less confusing way to do that. Because how can you really tell that it's a suffix, right? besides the fact that it lacks a, what, a forward slash right here. But forward slashes can also be implied. I don't know, it just seems kind of weird. The suffix path follows the same module resolution semantics. Okay, let's keep on scrolling down. Loading from the globals folder. If the node path environment variable is set to a delimited list of absolute paths, then Node.js will search those paths for modules if they are not found elsewhere. On Windows, node path is delimited by semicolons instead of colons. Node path was originally created to support loading modules from varying paths before the current module resolution algorithm was defined. Node path is still supported, but less necessary now that Node.js ecosystem has settled on a convention for locating dependent modules. Sometimes deployments that rely on node path show surprising behavior when people are unaware that node path must be set. Sometimes a module's dependencies change, causing a different version or even a different module to be loaded as the node path is searched. Okay. So be aware that node path exists, and if you're having trouble with your modules, node path might be part of the problem. Additionally, Node.js will search in the following list of global folders. 1. $home /.node modules. 2. $home /.node libraries. 3. $prefix /lib /node, where home is the user's home directory and prefix is the node.js configured node prefix. Oh, okay, that makes more sense now. So node prefix has to actually be configured. The node prefix that they were talking about, if we go up to here, this prefix here. So this prefix right here, from the loading from node modules folder section, that is, can we get back to where we were? That is from, hold on. That is from, defined by this node prefix right here. So this node prefix right here. That is, that's where that's coming from. Okay, so that makes a little bit more sense about how that works up above, but I probably still wouldn't do it if I don't have to, because it also looks like it's a holdover from a more archaic time. So let me restate the sentence since I kind of went off on a rant there. Where $home is the user's home directory and $prefix is the node.js configured node_prefix. These are mostly for historic reasons. Like I said, they seem kind of archaic. It is strongly encouraged to place dependencies in the local node_modules folder, where they will be loaded faster and more reliably. The module wrapper. Before a module's code is executed, Node.js will wrap it with a function wrapper that looks like the following. So we have an IFI here, and it is an unnamed IFI function, and the parameters are exports require module __ file name and __ dir name, and then / module code actually lives here. So that's just the basic structure of what's happening before a module's code is executed. So it looks like you don't have to write an IFI around your module code because it is kind of like bootstrapped into an IFI by Node.js itself, which kind of makes that nice. Because if you're using like ES6 JavaScript on the client side and you were using something like require.js, you would probably have to do this right here. You'd have to do that manually yourself if you wanted to avoid things leaking out into the global scope. Okay, let's keep on scrolling down here. So, by doing this, Node.js achieves a few things. If I can not... Okay, so by doing this, Node.js achieves a few things. Bullet point, it keeps top-level variables defined with var, const, or let scoped to the module rather than the global object. Bullet point, it helps to provide some global-looking variables that are actually specific to the module, such as bullet point, the module and exports object that the implementer can use to export values from the module. Bullet point, the convenience variables __ file name and __ dir name containing the module's absolute file name and directory path. The module scope __ dir name added in version 0.1.27 bullet point string. The directory name of the current module. This is the same as path.dir name of the __ file name. Example, running a node example.js from /users /mjr. Console.log __ dir name prints /users /mjr. Console.log path.dir name __ file name logs /users /mjr. Okay, file name __ file name added in version 0.0.1. Bullet point string, I think that is denoting the type of __ file name. The file name of the current module is the current module's file absolute path with symlinks resolved. For a main program, it is not necessarily the same as the file name used in the command line. See __ dir name for the directory name of the current module. Examples. Running node example.js from /users /mjr. Console.log __ file name prints /users /mjr /example.js. Console.log __ dir name prints /users /mjr. Given two modules, A and B, where B is a dependency of A, there is a directory structure of bullet point /users /mjr /app /a.js. Bullet point /users /mjr /app /node _modules /b b.js. References to __ file name with b.js will return /users /mjr /app /node modules /b b.js, while references to __ file name within a.js will return /users /mjr /app /a.js. Exports. Added in version 0.1.12. Bullet point object. A reference to the module singular .exports is a shorter to type. Sorry, I can't read. A reference to the module.exports that is shorter to type. See the extension about exports shortcut for details on when to use exports and when to use module.exports. Okay, so exports is shorthand for module.exports. That's important to know, because now that I know it, I'll always be typing it the long-handed way. Module. Added in 0.1.16. I just want to make a note here. Okay, so module added in version 0.1.16. It is a type of module. It has bullet point module, so I'm assuming that's what that means. A reference to the current module, see the section about the module object. In particular, module.exports is used for defining what a module exports and makes available through require. Require ID. Added in 0.1.13. bullet point ID, type string, module, name or path, bullet point returns, any type, exported module content. Used to import modules, JSON, and local files. Modules can be imported from node_modules. Local modules and JSON files can be imported using a relative path, e.g. ./.foo .bar ./bar/baz ./foo that will be resolved against the directory named by __dir name if any is defined, or if the current working directory. The relative paths of POSIX style are resolved in an operating system independent fashion, meaning that the examples above will work on Windows in the same way they would work on Unix systems. Okay. Importing a local module with a path relative to __dir name or a current working directory on Windows, this would resolve to ./path /mylocalmodule const mylocalmodule equals require in quotations ./path /mylocalmodule. Importing a JSON file, const JSON data equals require ./path /filename.json. Importing a module from Node modules or Node.js built-in module, const crypto equals require crypto. Okay, require.cache. Added in version 0.3.0. The type is object. Modules are cached in this object when they are required. By deleting a key value from this object, the next require will reload the module. This does not apply to native add-ons, for which reloading will result in an error. Adding or replacing entries is also possible. This cache is checked before native modules, and if name matching a native module is added to the cache. No require call is going to receive the native module anymore. Use with care. So adding or replacing module entries is also possible. This cache is checked before native modules, and if name matching a native module is added to the cache, no require call is going to be received. So I'm not sure what that is. Let's just keep going. I know I read something earlier about it being very dangerous to modify a loaded module because of the cache. Require.extensions. Added in version 0.3.0. Deprecated since 0.10.6. Stability is 0. It is deprecated. It is of type object. So, instruct require on how to handle certain file extensions. Process files with the extensions .sjs and .js. Require.extensions. Within square braces, we have a string .sjs equals require.extensions. Within square braces, we have a string .js. Not sure what that really means. So the extensions, it just looks like a remapping is what we have here. Yeah, I have no clue what that's about. Both keys, the .sjs key and the .js key both map to the same object. That's what that line says. I don't know why, though. Deprecated. In the past, this list has been used to load non-JavaScript modules into Node.js by compiling them on demand. However, in practice, there are much better ways to do this, such as loading modules via some other Node.js program or compiling them to JavaScript ahead of time. Avoid using require.extensions. This could cause subtle bugs, and resolving the extensions gets slower with each registered extension. Okay. Require.main. Added in version 0.1.17. The type is module. The module object representing the entry script loaded when the Node.js process launched. See accessing the main module. In entry.js script, console.log require main. node entry.js. Okay, so that is a console command right there. So node entry.js. And then down here, we have module, and then an open curly brace, and a whole bunch of key values. It looks kind of like a JSON object or some type of object literal printout here. We have keys, ID, path, exports, parent, file name, loaded, children, paths, and possibly some more keys that I can't see on the screen. So ID is just a string with dot in it. Path is / absolute path to whatever. Exports is an empty object. Parent is null. File name is absolute path to whatever. Well, I guess not whatever. Entry.js is the path to entry.js. Loaded is false. Children is an empty array. And paths, we have 4 paths: absolute path to node modules, absolute path to node modules, absolute node modules, and then / node modules. Okay, so we're just kind of like whittling down all the different possibilities to where there could be a node modules folder when we start going backwards from however deeply nested we are. So the very final path looks like it's the root / node modules. And so we're just recursively kind of chopping down the starting path from where we're running and just checking everywhere to see if there is a node modules. That's what I assume is going on here with this paths array right here. Okay, so let's keep going. Require.resolve, and then we have request, and then options, which is optional. And then we have history, so can this be opened up? Okay, so in our history we have versions and changes. So in version 8.9.0, the path option is now supported. And in version 0.3.0, added in version 0.3.0. Okay. Bullet point request is a string. The module path to resolve. Bullet point options is an object. And under options, we have a member that has been added to options called paths. It is a string array, paths to resolve module location from. If present, these paths are used instead of the default resolution paths. With the current exception of global folders like $home / .node modules, which are always included, each of these paths is used as a starting point for the module resolution algorithm, meaning that the node modules hierarchy is checked from this location. Returns string. Sorry, return string is another bullet point. So bullet point returns, and it returns a string. Use the internal require machinery to look up the location of a module, but rather than loading the module, just return the resolved file name. If the module cannot be found, a module not found error is thrown. Require.resolve paths, and then in brackets, bubble, I'm just going to call them bubble brackets. Deal with it. We have request. Added in version 8.9.0. Request is a string type, the module path whose lookup paths are being retrieved. And bullet point returns a string array or null. Returns an array containing the path searched during resolution of request, or null if the request string references a core module, for example, HTTP or FS. The module object. Added in version 0.1.16, type is object. In each module, the module free variable is a reference. Okay, so the grammar doesn't make sense. I'm just going to read it like it is. In each module, comma, the module free variable is a reference to the object representing the current module. For convenience, comma, module.exports is also accessible via the exports module-global, period. Module is not actually a global, but rather local to each module. Okay, module.children. Added in 0.1.16. It is of type module array. The module objects required for the first time by this one. Module.exports added in version 0.1.16. The type is object. The module.exports object is created by the module system. Sometimes this is not acceptable. Many want the module to be an instance of some class. To do this, assign the desired export object to module.exports. Assigning the desired object to exports will simply rebind the local exports variable, which is probably not what is desired. For example, suppose we're making a module called a.js. Okay, so we have some code here. Const event emitter equals require events. Module.exports equals new event emitter. We have a comment, do some work, and after some time emit the ready event from the module itself. We have a inline function wrapped in a set timeout for 1000 milliseconds. Module.exports.emit, and we have just ready. So it's going to emit a ready event is what's happening there. Then in another file, we could do const a equals require dot / a dot on ready. And basically we have some async code here. So on the ready event, we are going to console.log module.a is ready. Okay. Assignment to module.exports must be done immediately. It cannot be done in any callbacks. This does not work. X.js. Set timeout, and then after 0 milliseconds, module.exports, and we have an object literal with the key A and the value hello. And so that does not work, huh? Okay, and then in y.js, we have x equals require dot x require dot / x console.log x.a. Okay, got it, because it needs to immediately return, right? So let's scroll back up, make sure we got that. Assignment to module.exports must be done immediately. It cannot be done by any callbacks. This does not work. Okay, so we cannot use callbacks. Now the question is, can we use promises? It just has to immediately return, and a promise does immediately return. I will leave that as an exercise to the reader, or me for later. Can module.exports return using a promise? And I don't know if that is something that can be done or not. Let's just keep on reading. Exports shortcut. The exports variable is available within a module's file level scope and is assigned the value of module.exports before the module is evaluated. It allows a shortcut so that module.exports.f equals ... can be written more succinctly as exports.f equals ... However, be aware that, like any variable, if a new value is assigned to exports, it is no longer bound to module.exports. Module.exports.hello equals true, exported from require of module. Exports equals, and assigning an object literal, hello, : false. Not exported, only available in the module. Okay, interesting. Module.exports.hello equals true. Exported from require of module, but exports... so I'm not sure if they're saying that you gotta do module.exports. This is not exported. So let's scroll up here again. Let's read that again. However, be aware that, like any variable, if a new value is assigned to exports, it is no longer bound to module.exports. Oh... Okay, so I believe that what they're saying is exports is shorthand for module.exports, right? So this exports here is just shorthand for module.exports, right? And so if we do this right here, we're not actually exporting, and it's only, yeah, it's not actually exporting because we're just overriding the synonym, right? So doing this is just overriding the synonym. And so that's interesting. So I feel like I might want to look at some of my code really quick, because that could be something that I was doing wrong, and maybe all this reading has actually been worth my time for that one piece of knowledge. So if I am looking at, I had a, I think it was this. Oh no, this is my third-party stuff. Okay, so I have some tables that I'm exporting, right? And right here, we have const, and then we have this table, right? And it's an object. It looks like I removed the exports from this already. So I can't be sure, but I was doing exports dot instead of module.exports because it's a shorthand and assigning it to this object. So module.exports, but I still added this on, I believe. But maybe I didn't. Maybe I missed something. So I might want to try that again. But yeah, that's important to note. So I'm just making a note of that I can go back to. So I'm just going to copy that right now. Okay, so anyways. So this is something... so this is another reason how earlier I was saying you should probably do things long-handedly rather than shorthand. And we already have a problem that can result from doing things in a shorthanded manner. Because otherwise, right, if we did module.exports equals, if we did modules.export equals this, that would still be kind of bad, but the behavior would be to override whatever we did previously. And honestly, that would seem less weird to me than this behavior here. I mean, I guess they both make sense when you realize exports is just a synonym. It's a shorthand variable, but it's not like a define, right? So this is its own variable that exists separately from this. It just references this. Now, if this were like a C define, then this would be an override, but that's not how this synonymous behavior works. Okay, so let's keep on scrolling. When the module.exports property is being completely replaced by a new object, it is common to also reassign exports. Module.exports equals function, constructor, and then inside this constructor function, whatever. Okay. To illustrate the behavior, imagine this hypothetical implementation of require, which is quite similar to what is actually done by require. Okay, so we have function require. Oh, let's scroll a bit. Function require and some string in there, or, well, it's... Actually, I'm not sure what that's about. I guess maybe some optional parameter. I have no clue. Is this pseudocode? Is it not pseudocode? Why is that there? If there was at least a comment in there, it would make more sense. But yeah, I don't understand that. But anyways, function require There's 0 parameters, but a comment that might suggest something. I don't know what. Possibly that you can optionally put parameters in there if you want, maybe. And then within the body of the function require, we have const module equals open curly brace exports, and the value of the exports key is an empty object. And then we have what looks to be an IFI, and it takes parameters module and exports. And within this IFI, also this IFI is executed with module and module.exports. Okay, and within the IFI, we have module code here in this example, define a function sumfunc, and it's just an empty function. Exports equals sumfunc. At this point, exports is no longer a shortcut to module.exports, and this module will still export an empty default object. Module.exports equals sumfunction. At this point, the module will now export sumfunc instead of the default object. And that's the end of the IFI that is inside of our require function. And then at the end of the require IFI, we have return module.exports. Module.filename. Added in version 0.1.16, the type is string, the fully resolved file name of the module. Module.id. Added in 0.1.16, it's a string, the identifier for the module. Typically, this is the fully resolved file name. Module.loaded. Added in version 0.1.16, the type is Boolean, whether or not the module is done loading or is in the process of loading. Module.parent. Added in version 0.1.16, deprecated since version 14.6.0. Stability is 0. Deprecated, please use require.main and module.children instead. So, looks like you can reference the main module, and you can if you want to go downstream, you got to go all the way upstream to module.main. And downstream, you can just do module.children. I'm not sure why it doesn't let you backtrack with module.parent anymore. Let's read on. So the type of module.parent is one of 3 types: module, null, or undefined. The module that first required this one, or null if the current module is the entry point of the current process, or undefined if the module is loaded by something that is not a common JS module, e.g. REPL or import. Module.path. Added in version 11.14.0. Type is string. The directory name of the module. This is usually the same as the path.dirname of the module.id. Module.paths. Added in version 0.4.0. The type is string array. The search paths for this module. Module.requireID. Added in version 0.5.1. The ID is string, returns any type, exported module content. The module.require method provides a way to load modules as if require was called from the original module. In order to do this, it is necessary to get a reference to the module object. Since require returns the module.exports, and the module is typically only available within a specific module's code, it must be explicitly exported in order to be used. The module object. Added in version 0.3.7. Type is object. Provides general utility methods when interacting with instances of module. The module variable often seen in file modules. Accessed via require module. Module.built-in modules. Added in version 9.3.0. v8.10.0, v6.13.0. The type is string array. A list of the names of all modules provided by Node.js can be used to verify if a module is maintained by a third party or not. Module in this context isn't the same object that module in this context isn't the same object that's provided by the module wrapper. To access it, require the module. Const built-in equals require module dot built-in modules. Module dot create require, and then a file name. Added in version 12.2.0. File name. Bullet point file name is either a string or a URL. File name to be used to construct the require function must be a file URL object, file URL string, or absolute path string. Bullet point returns, and it returns a require. So there's an actual type called require, and it is a require function, I guess. Okay, we have some code here. Import in a deconstructor, create require from module. Const require equals create require, invoked with the parameter import.meta.url. Comment sibling.module.js is a common JS module. Const sibling module equals require with the path ./sibling module. Okay, let's look at module.create require from path file name. Added in version 10.12.0, deprecated since version 12.2.0, so they changed their mind pretty quickly. Stability is 0. Please use create require instead. Should we really be reading it if it's not stable? Let's for consistency and covering everything, let's cover everything. So there's two parameters here. Well, not parameters. One's an input and one is an output. Bullet point file name is a string file name to be used to construct the relative require function. Bullet point returns require, and it returns a require function. We have some code here. Const, and then within a deconstructor, create require from path equals require, and then module within a string. Const require util equals create require from path, and then /src/utils/ //require. Sorry, that's a comment. So the comment is require /src/utils/ /sumtool. Then it says require util, open paren, and then within quotes, /sumtool, close the quotations, and close the require call. So the require util looks like it is allowing us to, by using create require from path, we can, shorten how we are making our require tools here. And honestly, I would not do this. I would not do this in the recommended way with the new function, and I would not do it with this old function. I would honestly just, like, I don't understand why you would do this, just to like save a few lines of typing and to add more mental indirection. Like, that's, I don't know. That seems like nonsense to me. Maybe there's some reason, but if the reason is just to make the lines shorter, and that's stupid. Don't do that. Like, you're a programmer, you can type fast. Just don't do that. Module.sync built-in ESME exports, or sorry, module.sync built-in ESME XPORTS. Man, I cannot say that without stuttering it. And this is also why camel case annoys the hell out of me when I'm writing function names. Because of this. Like, camel case, everything's good with camel case until you get an abbreviation, you know? And then this just sucks. Anyways, module.sync built-in ESM exports. Added in version 12.12.0. The module.sync built-in ESM exports method exports all the live bindings for built-in ES modules to match the properties of the common JS exports. It does not add or remove exported names from the ES modules. Okay, and then we have some code down here. Const fs equals require fs. Const, and within a deconstructor, we have sync built-in ESM exports equals require module. fs.readFile equals null. Delete fs.readFile sync. fs.newAPI equals function new API. So this just looks like an example of how to why are we editing a read file, and why are we editing this fs object, and what does this have to do with any of it? So it looks like we have later down in here, we have this call to sync built-in ESM exports, which must be doing some type of weird magic. This is more stuff I just would not do. I would not be modifying packages. I would be trying to make, I get why you would want to, if you absolutely have to patch something, I guess you would do it, but otherwise I just would not do this. So import fs.then, we have .then, and then it's going to take the parameter esmfs, and within this callback function invoked by the promise.then, we have assert.strict equal esmfs.readFile, comma null. Another line, assert.strict equal readFile sync in fs, comma true, assert.strict equal esmfs.newAPI, undefined. Okay, so let's keep going. Source map v3 support. Added in version 1.3.7.0. Stability 1 experimental. Helpers for interacting with the source map cache. This cache is populated when the source map parsing is enabled, and source map include derivatives are found in modules folder. To enable source map parsing, Node.js must be run with the flag ... enable source maps, or with code coverage enabled by setting node v8 coverage equals dir. Const, and then within a deconstructor, we have the variables source map and source. We have the variables find source map and source map within a deconstructor set to equal require module. So we're just taking out find source map and source map from the module. Okay. Module.find source map with path and a optional parameter error added in version 13.7.0. We have path string, the error, which is of type error, and it returns module.sourceMap. Path is the resolved path for the file for which a corresponding source map should be fetched. The error instance should be passed as the second parameter to find source map in exceptional flows, e.g. when an overridden error.prepare stack trace with parameters error and trace is invoked. Modules are not added to the module cache until they are successfully loaded. In these cases, source maps will be associated with the error instance along with path. Okay. Class module.sourceMap added in version 13.7.0. New source map and then a payload. The payload is of type object. Create a new source map instance. Payload is an object with keys matching the source map v3 format. There are some bullet points. I believe these are going to be members of payload object. And we have 7 bullet points. Number 1, file, type string. 2, version, number. Bullet point 3, sources, is a string array. Bullet point 4, sources content, is a string array. Bullet point 5, names, is also a string array. Bullet point 6, mappings, is a string, and bullet point 7 is source root, which is also a string. Source map payload returns object, getter for the payload used to construct the source map instance. Source map.find entry with parameters line number and column number. It has 3 bullet points here. Line number is of type number, column number is of type number, and it returns an object. Given a line number and a column number, in the generated source file, return an object representing the position of the original file. The object returned consists of the following keys: generated line with number. So we have some bullet points. So the object return consists of the following keys. So these are the keys within the object that is returned by source_map.findEntry. We have 5 bullet points. Bullet point generated line is type number. Bullet point generated column, also of type number. Bullet point original source, type string. Bullet point original line, type is number. Bullet point original column, type is also a number. And that is all for the Node.js documentation for version 14.8.0. Sorry, that's not all the documentation for Node.js, but that is all the documentation for the modules. And why does it... What am I missing here? Yeah, that's kind of confusing because it's like table of contents, modules, and the header for this doesn't really mention that it's just modules, but up here in the address bar, you can see it's just the documentation for modules. So I'm done reading this, and that took me an hour and 26 minutes. Oh boy, okay.